Swayam Prabha. Digital India. Educated India.
Good morning again to our course on Introduction to Mechanical Micromachining. In the last class, we were discussing about the microfactories, and we have seen that there are a lot of advantages in terms of the cost and the different technical aspect also, and we continued that what are the things which we have to take care during the use of this particular type of machines. So, let us continue our discussion on the advantages of the microfactories. So, we have seen one advantages related to the economic aspect, and we were on the technical and engineering aspect. So, what are the things? The other thing is the precision, freedom of configuration and proportion in the machine design will increase. Now, we know that in the last few lectures what we have seen that suppose you want to move something here to here and this distance is only 1 centimeter, then actually you have a lot of things that now your accuracy distance is this much with a accuracy of 1 micron, right. And now this is the one thing, and this is the another example where the distance is 1 meter, and again you need the same thing that with a accuracy of 1 micron. So, here actually it is a achievable, and here it is a difficult thing, because now we know that at a meter scale what is requirement, your requirement is a micron, but here it is in centimeter scale 1 centimeter, and suppose it is 25 millimeter. So, 25 it is 1 centimeter 10 millimeter only. So, within 10 millimeter you need a 1 micron. So, here whatever there are many things which are available, you can make straight very finely, because straightness is not a issue at a smaller scale, but straightness is big issue when you are talking about the large dimension here. So, when you are talking about the small scale where your movement of the axis are in the 10 millimeter or 20 millimeter kind of thing, then you can actually make the system very precise, and so you do not have any type of axis movement problems or any type of other movement things. So, and other thing is you have freedom of configuration. So, now you want to make 3 axis component, then you can actually use some type of highly sophisticated small motors, and you can actually configure your system very fine, and which is not the case of the bigger size of machines. Right. High structural loop stiffness and resonance frequency. This is actually the debatable things here. The stiffness is high in terms of the components only, because smaller components are very difficult to deform. In that way it is there. But when you consider the loop stiffness of this particular part, that means when all things are connected with each other and there are some vibration, the whole structure will actually the under vibration, not the individual component. So, if you talk about individual component, you have a high structural loop stiffness, that is the good thing, and resonance frequency is very high. So, that is the reason that you can go with a high speed and the high translation motion without any problems. Short-term ramp-up time, that means the time you put the machine into the workshop and then you start installation, then doing some type of preliminary experiments, those things called the ramp-up time at this particular definition. So, one can proceed to mass production immediately after setting up the machinery for small quantity production by just increasing the number of machine. So, in that case what happened that you want to increase the production here. Suppose you want to increase the number of components to be machined by bigger machine, then what you have to do that you have to buy 2 or 3 machines. Again it will take some time in terms of the installation and then training and all these things. But when you buy a small machine something like that, then what happens that you can actually start the you can actually reduce this particular operation, that means the installation process and the learning process very quickly in a small machine. So, that is the advantage for this particular aspect. Environmental aspects. So, what are the environmental advantages? First is the saving energy and material resources, because material resources are many. Material resources are related to the machine components. that is the machine component. Then related to the auxiliary equipment. So, that is equipment or the material related to coolant what we are using. So, that will be also very less. The suppose you want to do some type of cleaning operation there. So, you have to spend less time here because the size of the machine itself is very small. You can keep the spaces very clean compared not around the on the machine, but around the machines also. So, at that time you require very less amount of material resources. Reduce vibration and noise for workers and the factory's neighbors. So, this is also advantage because if your machine is very small, vibration and noise is most related to the moving components, if there are lot of moving components, but we know that our operation will be very is done by the very small machine, the motors and everything. So, your noise level will be very low compared to the bigger size machine. Vibration is obviously low because we are using very small component and also doing a machining of on a small component. So, vibration from the machine will be less, but vibration from the outside sources may create some problem in the machining process. And factory neighbors, because if the machine is very heavy and very old, then it creates the noise and the vibration to the nearby places also, but that is not happening in the micro factories. Easier control of the waste and pollution, because we know that suppose chips and everything is very placed here and there on the machine itself, then cleaning is not a problem here because space is very small. And pollution also, that is related to the removal of this coolant and some type of other liquids. So, you can easily actually clean without any problem. So, you do not get so much of problem from the waste and the pollution in the micro machines. Human related aspects, machine can expand into educational and hobby fields, opening the door for the new users. Now, what happens that there are cost is also issue, because if you see this first machine which was shown in the red color, that was Carnivo, the cost is in terms of crores. But if you want to learn something in terms of educational hobby, that means suppose you want to understand how machining is being done at the micro scale and what are the problems that we have discussed in the last many classes, that how things are different in the micro scale and the macro scale, then you actually do not require such a big machine. You can buy a small machine which are comparatively very cheaper than the bigger size machine, and you can actually learn that how micro machining is done. If you are comfortable and you understand all the material related aspect and the process related aspect, then you can directly go to the bigger size machine where you can be an expert in the operating those big machine. So, this is very big advantage because you do not need to do some capital investment for learning the machine. You can learn all the things by a small machine with a less cost, and then you can do the rest of the part on the bigger machine. Right. It will help train the people who will take the responsibility for manufacturing in the next generation machine. So, training is also very big issue here, because when we know that there are lot of differences between the conventional machining and the micro machining. So, you can actually do all these things by learning itself, but unless you do this hands on experiment, you will not understand that how things are very difficult. In the lectures, we understand that you should not move your component from 1 micron to 10 micron very quickly, something like that, but telling it is easy, but when you actually operate the machine, you do not understand whether you have moved 1 micron or 10 micron. So, unless you put your hands on the micro machine, these things are very difficult to understand. So, training is very important, and for training, if you actually occupy the big machine which are very costly, then there is a problem with the production unit and the cost associated with those machines. So, better you put some micro factories or micro machine, then train yourself with the different parameter setting, that which particular parameter settings are useful for getting the right product out of the machine. So, parameters you can replicate on the bigger size machine also, because parameter setting will be almost same for both the cases, and then you understand that how the different material and different tool materials will play important role in getting the right product out of it. So, training is very important, then you can actually understand this machine as a education or the hobby field, and those things are related to the human aspect. But these are the advantages, but there are a lot of problems in the micro factories also, because we know the advantages are many, but still why these machines have not come up in the market, then because there are many challenges also. first thing is that they require accurate sensor and actuators which must be small enough to implant within the machines. Now, this is the big machine because we know that we are operating at a micro scale. So, machine is micro scale, micro machine plus micro component. So, visibility is very less. Visibility in terms of that means suppose something is going wrong in this, one thing is your machine itself is very small, another thing that you are cutting something which is also even smaller than that. So, the response or some type of signature coming out of these machines are very small, because we have seen in the bigger size machine also you cannot understand by means of some noise or some type of other things which is coming out of the machine, but here you are further going down into the size of that particular machine. So, you will not understand anything out of that. So, what is the thing that you have to put some sensors and actuators in this machine. So, now problem is that you have to reduce the size of the component of this also, because when you are talking about this thing, then the size of the sensors and other component should be also reduced proportionally. Right. Now, what is the problem here, that this, suppose this is fabricated by some company, micro machine you can get somebody from other company, then you have to actually look for the sensors and actuators from the other company. Now, what is problem, that now integration is a big problem. Now, you do not have space here, the space is the limitation. Limitation is the installation space. Right. So, this is the first thing, that where do you install that, because you have already crammed many components related to the machine part also, because you have 3 axis motors also moving from one location to another location, you have Z spindle motor also there, then you have to put some sensors so that you can put some, at least some camera, so that you can understand what is going on there. Then you need actuator also for moving this X, Y and Z, that is sometimes you do not require motor, but you put some actuator in such a way that where few millimeter stroke here and there, it is easily achievable. So, space is a big problem here, because you have already crammed many components here. So, putting some extra component, you have to think that where you are putting there. Another thing, that size of this part should be also small, otherwise if it is not small and it is bigger size of that, then sometimes your sensor size is bigger than the component size what we are immersing here. So, these are the some problem associated with the monitoring and the control of the micro machines. Structural rigidity of the micro machine tool is less than those of the precision machine, because earlier we have seen that it has a high structural stiffness, but this is related to the machines, because if you put a bigger size of component, the vibration coming from the outer surface or the outer environment will not create more problem if the machine is a bigger size. That means inertia also play important role, vibration will not affect in it at such a small scale. But if the machine size is very small, then you will get the vibration from the outer surface in the system very quickly. Further studies are needed to improve the rigidity of the microfactories, because mostly this is the big problem here. So, most of the research which is going on acceptance of this microfactory in the actual environment, it is related to the rigidity only, the how you can improve the rigidity of the machine, and that so that you can use this thing more frequently compared to the costly micro machining centers. Micro machine tool can be excited by the external disturbances. So, that we are, this is all things are coupled, because small disturbance is enough to get a signature of that external disturbance on the machine surface. So, that is the big problem here. So, we have to apply some type of vibration isolation, so that you can actually get the desired tolerance within the in the component. Vibration isolation, that means you put some type of pneumatic table at that. So, vibration whatever is coming from the outer surface, that means from the nearby machine or from the floor, that can be actually completely isolated and it will not transfer to the machine if you use some vibration isolation. So, now let us take some example, what are the different machines right now available. Some of them are the researchers, some of them are already in the market. So, this is the micro lathe. So, it is a smaller than a human palm, was developed in 1996, and see the size, it is at 32 millimeter long, 25 millimeter wide and 30.5 millimeter high, and weight is only 100 gram. Now, we have to see that what this machine can do. So, it has XY linear stretch given the piezoelectric actuator, because why we use actuator here, because we do not require lot of travel here. When you require lot of travel, then you have to use some type of servo motor or stepper motor, and then you use a lead screw or some type of recirculating bolt screw or something like that. But our stroke length is very small, so you do not require some type of motor, but actuators are enough to give this type of particular stroke. Spindle motor is 1.5 watt and it can turn at about 1000 rpm, 10,000 rpm. So, that is acceptable with a small amount of job and some type of very soft material. So, example was given related to brass material. So, brass was machined with accuracy of 1.5 micron roughness in the feed direction and 2.5 micron on the roundness, because we know that when you do a turning operation, this is the component what we want to machine. Then what happens, that first thing is that this is the 1.5 micron is the roughness. So, this is what we are talking about, this thing, that is the on the feed direction. So, this is in feed direction, and when you are talking about the roundness, then you have to do measurement at a different cross section, that what is the difference in the diameter. So, that is related to this particular thing. So, that is means you will get the variation within a 2.5 micron in terms of diameter, and the roughness you will get the 1.5 micron in this particular direction. Okay. Minimum diameter was produced of the 60 micron. So, you can see that by getting a 60 micron and spending crores of rupees on that, and when the material is same, you can still use this material, this particular micro machine, if this accuracy and this particular roundness and the roughness are according to your requirement, then you do not require a very large machine for doing the same job. Then the second version of that earlier machine was the numerically controlled machine, because here you are using a normal NC program which we are using for routine cases. So, this is the another machine which has a footprint of 550 by 450 millimeter, and linear encoders are used here with a resolution of 62.5 nanometer resolution, because we have seen that whatever machine has some resolution, the resolution of the encoder should be at least 10 times higher than the machine resolution, then only you can extract the maximum benefit out of the machine. And it has a single board custom NC numerical control which processes the part programs and the feeds of the servo control with a 0.1 micron resolution. Because now once you have CNC program, then what you have to do, you have to process this part also, and you have servo controller which will move your axis in XYZ direction depending on the number of axis. So, here that is the 0.100 nanometer is the resolution of that thing. And here also the example was the brass. So, they turned the brass, and the RZ is the 0.5 micron and RA was the 60 nanometer. So, what is the RZ and RA? So, suppose this is the roughness profile. So, RA is actually the average of this particular signal. So, this is the average roughness. And RZ actually it will find out what are the 5 highest peaks. So, this is the one peak, this is the second, third, this is the fourth, and this is the 5, and 5 highest peak and 5 highest valley. So, this is the 1, 2, 3, 4 and 5, then average of these all 5. So, you can see that this thing is talking about the highest value only. So, it has a higher rating here, that means the value of the RZ is higher, always higher than the RA value, because this is the average. So, all the small peaks also will be counted in the calculation of RA. So, if you want to see the what is the actual picture of this part, then RZ is the right parameter compared to the RA, because many different surfaces have the same RA value, because it is the averaging value of the many components. Right? And roundness error was the less than 0.5 micron. So, this is showing much better result compared to the earlier case, but so this was the means what we can say, this advanced version of the earlier micro lathe. And this is the component which was processed. Here you can see the whatever the features it was created because of the NC program, you can give the curvature also, then you create a slot also, and you can understand how fine it is produced. Portable micro factory, because in micro factory what we are talking, we are using a different machine at the in a very small group, so that you can get different product in terms of the different processing parameters. So, here what is there? This is the micro milling machine is there, this micro press is there, transfer arm is there. Suppose you are doing some machining at these two location and then you want to transfer that thing to other location, then you can use transfer arm there. And micro manipulator is there, that means for moving placing a component there, then holding for some by some type of gripping, then you can use this part. So, if you put this 4 machine together, many different type of jobs you can produce without any problem. So, micro milling and a press are assembled on a desktop together with a micro transfer arm and a 2 finger micro manipulator along with a micro lathe. Lathe is not shown here, but it is also installed, we will see in the next figure. So, what are the things about the micro milling machine? So, the area is 119 by 102 millimeter, 36 volt brushless DC motion of use, and it can rotate up to 20,000 RPM, and can do surface cutting, drilling using the micro tools with a 3 mm. So, 3 mm shank diameter is a very common in all the micro machining cutting tool which are available, because this is very standard and you can easily get the collet with a 3 millimeter of diameter. Compared to related to the press, now press has this much area and 100 watt AC servo motor is used, and you can get the 3 kilonewton of load on the particular press. And rotating motion, because now here you have to press something. So, pressing getting that much amount of force is very difficult. So, what they are doing, they are actually converting the rotational motion in terms of a linear motion. So, they are using a timing pulley bed, and then by rotating it you are pressing a punch on the down surface, and then you can get the required geometries. The press speed and the dead point of the press stroke can be digitally controlled. So, there are some microcontrol available which will do all these parameter settings. Micro transfer arm. So, this is the third component. It has a working volume area circle is the 200 millimeter. So, it is very large compared to the area of this. So, you can actually move one component from one machine to another machine very easily, because you can see that it is a 200 millimeter is very large. So, you sometimes you do not require so much of space between these two. So, you put this micro transfer in between these two machines without moving any of this thing, it will take out the component from here and then it will place at the micro press, or the other way around also. And horizontal position accuracy is 20 micron, because now when you place component from one location to another location, then it has a 20 micron. So, within a 20 micron of a position accuracy you can get the machining done. It has a 3 translation degree of freedom and the 1 perpendicular wrist rotation. So, you can move in a circular wave also, and then you can move in the 3 translation directions. Now, coming to the last one, that is a micro manipulator. So, it has a finger working range is 100 by 100 by 30 microns. So, within that area you can actually grip any component from there. Resolution of the finger motion is 1 micron or less. So, when you want to pinpointly you want to target something, then you can go with a 1 micron. So, that is the advantage of 1 micron. Largest controllable object is 200 micron. That means, how much amount of things you can move from here to here. So, that is the object. That means, if the object size is 200 micron, you can actually easily place from one location to another location. You can manipulate the movement of that component. And finger module has 3 integral piezoelectric actuator, because when you look at the very small area or something, at that time it is better to use some type of actuators which are energized by means of some type of electrical supply instead of using some motors. And this is the component, these are the different components which are fabricated using this particular setup. Now, you can see that ball bearing with a 0.9 millimeter OD and 0.1 diameter is the shaft diameter. This is under shaft, this is the cover, and this is the housing, and the ball is the steel balls are available here. So, one bearing assembly is completely fabricated by sequence of different operation by this particular micro factory arm. And if you assemble all these thing in a single part, so this is the full assembly of all that component. Now, you can see that this is the press is there, then this is the manipulator is there, then is the transfer arm, then this is micro milling machine. Now, once you do machining here, what is happening that you cannot see anything by naked eye. So, here there is a visual instrument is available and you have a joystick. So, by joystick you can operate the machine, because we know that by operating or moving component by means of hand, it is very difficult here, because you cannot sense also that how much force you are applying or how much is the component size is there. So, if you assemble everything in a single part, so total box size is the 625, 490 and 380 millimeter is the area, and weight is 34 kg only. So, that is the advantage. Many machines you are putting together in the same part. So, machines are controlled manually using the two multi-degree of freedom joystick and visual aid for the operator. So, this is the visual aid, because you can see that the machining is being done. So, you put one camera here. So, camera will tell you that what is happening at this location, and power consumption during the operation is just a 60 watt. So, you can see that many things can be done without actually spending lot of money and the resources for the bigger size of machine. Now, this is the one thing about the 5 axis micro milling machine. Now, you can see that this is the other part. So, now you can see that if you want to increase the what we can say the capability of the machine, then you have to put more and more amount of axis on the top of that. So, earlier whatever we have seen, that maybe the 3 axis machine or the lathe and other things are there, but here it is a 5 axis machine. And here what you can do, that you rotate the workpiece here, and then you can give the inclination to the z axis in that particular c direction, so that you can do some type of taper cutting also without any problem, and these are the standard x, y and the z axis are there. And this is the actual photo where you can see that this is the spindle available. Spindle can rotate in this direction, and this is the thing, the workpiece has the second rotation, because now suppose you have a one job here and you want to drill at this location. So, what you can do here, that you can actually instead of moving your tool in that direction, what you can do, you can index the surface, right. So, first you drill over here, that drilling is over, then you rotate your workpiece at this location. So, this part will come here and then you do indexing. So, indexing is much precise compared to the movement of the cutting tool. So, that is the advantage of using the A axis, that is rotation around the x axis very easily. So, overall size is the almost 1 feet by 1 feet in terms of height, but it is 294 by 220 is the width and the length. So, what are the feed system is the 3 precision linear motions are there for x, y, z, and 2 precision rotary stage are there, that is for A and the C axis here. So, this is the specification of the spindle. So, spindle can rotate up to 20,000 to 30,000 rpm, power is 63 and the torque is 0.8 kilogram per centimeter, and run out is 2 micron. Now, you can see that when you go with a down and down with the size, the maintaining run out at the lower scale is also very easy, because here you do not require you are actually working with a very small amount of component, and you will not get high heat generation or the different problems also. Related to the axis specification, now it has a x, y, z and AC axis. So, x, y has the total travel range 20 millimeter. So, if you want to do machining within 20 millimeter, you can do that. Resolution is 50 nanometer. Z means vertical travel, you can accommodate a component with a 30 millimeter of height with the same resolution. And A and C axis, what you require, that you require the rotation of the. So, you can see here the C axis is a very high, because if you want to maintain the tilting angle with a very high precise motion, then it has a 0.0012 degree and it is a 0.02 degree. So, by making this particular system, you can do lot of different type of jobs. So, let us see those things. What are those things? So, this is the one component which was fabricated by that earlier machine. So, machining of micro walls, material was the brass, carbide flat end mill of 200 micron was the diameter of the end mill cutter, and 25,000 was the RPM, cutting depth was a 5 micron and feed depth was 1 millimeter per second. Now, you can see that how fine features you can create, and the cost of this machine is obviously lower than the bigger size of micro machine. So, if you see that these are the fine features, there is no bending of this part also there, because we have seen that if you reduce the wall thickness at the later stage, at one instant that your wall will be in bending, because it will not take the lot of forces from the cutting tool. And this is the magnified view, and you can see that these are the very finely features and the size you are also not getting lot of amount of burrs. So, that is the advantage of using this particular part. Another example that you can see that this is a very circular, long circular micro column is there. So, it is in the square section, and there was another one that was fabricated by this rectangular section also, but not shown here. Again the material is brass, cutting depth is 5 micron here. So, every time you are going 5 micron and with a step over of the 5 micron. So, 5 micron and then again go 5 micron down, and that way you can fabricate the big component. Now, you can see that there are a lot of advantages associated with this type of micro machining processes, and if this particular requirement is fulfilled by your smaller machine, then it is better to use this smaller machine compared to the big machine. So, let me stop it here, and we are finishing this micro machine lecture here itself. Thank you very much.